So if it says if you drop a ball from a 100-meter high cliff, how long would it take to reach the ground below? All right, so this is a free fall problem, right? Because we're dropping a ball from a cliff, it's falling downwards. So that's gonna make one more given. I told you he wasn't important. Now he is. Okay, so what do we have? What are the givens here in this problem of the day?
We got the distance.
Yeah, we've got the distance it falls, right? How far is that?
And it is
100.
negative 100 meters.
Yeah, that's right. That's right. It's important that you said negative 100 meters too, right? Because it's moving downwards. So its delta y is going to be negative, right? Because it goes from a higher place to a lower place. It falls. It goes down 100 meters. So that's negative. And that's important to remember that. That'll make us make fewer mistakes later on. Great. So we've got delta y is negative 100 meters. What other information do we have?
Acceleration.
Yeah, we have the acceleration, right? Because we know we're in free fall. What's the acceleration always going to be in free fall?
Negative 9.8.
Perfect. Negative 9.8 meters per second per second. Good. So we've got a displacement, we've got an acceleration. Is there another piece of information that we're given or that's implied?
I think it's the final velocity.
The final velocity. What would the final velocity be?
It's gonna be 0.
Well, it would be, so it'll be 0 after the ball lands, right? And it hits the ground's going to slow it down to 0. But as it's falling, right, it's going to have some speed as it impacts. So its final velocity, we don't know what it is. We don't know how fast it's going to be going when it hits the ground. We can't count the 0 after it hits the ground because the ground's going to put a big acceleration on the ball and bring it to a stop. So we don't know the final velocity. We don't know its impact speed. And that's a good thought. There is something that we do know, and it has to do with the fact that we're just dropping the ball instead of throwing it. I think a lot of you know what this one is. If I just go, yeah, go ahead, say that again.
Initial velocity.
Yeah, initial velocity, right? It's when I let go of the ball, it's not moving yet. So I'm just dropping it. So it's my initial velocity that's 0, not my final velocity. And the final velocity, I don't know. So the givens I have are displacement, acceleration, and initial velocity. What's the unknown that I'm looking for?
Time.
Right, the time. How long does it take, it says, right? Okay, so I have my delta y. I've got acceleration, vyi, and delta t. Right, so which of the kinematics equations has those symbols in it? It looks like it has all of them except for final velocity.
The third one.
Yeah, it's the third one, right? It's the third one that doesn't have the final velocity in it. So I'll copy that down. Let me use the y instead of the x. So delta y equals initial velocity times time plus 1/2 times acceleration times time squared. And we will need to rearrange this, right? We've got to get the delta t all by itself, since that's what we're looking for. And it's important that in order to do that, we realize that since our initial velocity is 0, the initial velocity times anything else, 0 times anything is always going to be 0. So this whole first term is going to be 0 in this case. If we rewrite the equation, then it becomes much easier to rearrange. We don't have to do a quadratic equation. we just have delta y is 1/2 times acceleration times delta t squared. And since it's the delta t that I'm looking for, I'm going to divide this other stuff out of the way. So if I divide both sides by 1/2 acceleration, it cancels out on the right. And on the left, I'm going to do the same thing, except instead of dividing by 1/2, I'll multiply by 2, which is the same thing. So what I'm left with is the time squared equals 2 times displacement divided by acceleration. And I'll only need to do one more last step to get my time, right? If I've got the time squared, what's the last thing I'll need to do to get the time by itself? How would I undo a square?
Do you square root it?
Yeah, exactly. Square root it, right? If what I'm looking for is squared, I have to do the square root to undo that. So if I take the square root of both sides, I have delta t is square root of 2 times displacement over acceleration. All right. That one is tricky to rearrange, especially if you don't remember to plug in the 0 for the initial velocity first. If you're having trouble rearranging it for delta t because it's there in 2 places, you might want to try to think about if anything is 0 and any of the terms just disappear. But anyway, now we can go ahead and plug numbers in. So we've got the square root of 2 times negative 100 meters and divided by negative 9.8 meters per second squared. So then we can plug that into the calculator. And we'll do square root of 2 times negative 100 divided by negative 9.8. And we get 4.5 about. So our time is 4.5, and the units is going to be, well, if I've got meters divided by meters per second squared, that's seconds squared. And if it's square rooted, then it's just seconds. So my time is 4.5 seconds. Seconds works out. That's the SI unit for time. And 4.5 seconds for dropping off something from a pretty high cliff seems like the right amount of time for it to land.